All right, you guys, let's go over some of these homework problems that we had for solving log equations. Let's start with number 1. The log of 5x equals the log of 2x plus 9. If you remember what I was saying, that a log is just an exponent. I'm sorry, my writing skills are not not good today. If you remember that a log is just an exponent, and you remember all those problems with the exponents that we did where if they had the same base, you could just set them equal to each other. Well, this makes sense. Both of these logs are base 10 because they don't have any other base, so it's automatically a base 10. So that means we can just set 5x equal to 2x plus 9. Okay, so now we're just solving for x, which means we need to get x by itself. The first step is to get x. The x is on the same side. Okay, and I'm not going to baby you guys talking about every single step that I'm doing, and divide each side by 3. So for number 1, x equals positive 3. Okay, didn't even need my calculator. We definitely need some harder questions. Let's try number 2. Let's see, number 2. The log of 10 minus 4x equals the log of 10 minus 3x. Okay, both have log base 10. Let's go ahead and just set them equal to each other. All right, I'm going to add 4 x's to both sides, and I'm going to subtract 10 from both sides. I'm just going to do this in the same step. Okay, and as you will see, this cancels too. This whole side becomes 0 equals, this cancels, and I have 1x, negative 3 and positive 4 is 1x, but remember we just read it as x. I've already solved this one. X is equal to 0. Let's see, number 3. Is there anything, I'm looking down at this paper. I'll do number 3, and then I'll skip down and do some of the harder ones on the bottom. But the other ones in between the here and there are all the same. So let's see. Number 3 says the log of 4p minus 2 equals log of negative 5p plus 5. I'm just going to go ahead and set them equal to each other. 4p minus, since their bases are the same, minus 2 equals negative 5p plus 5. So I will add 2 to both sides to cancel this out here. And at the same time, I'll go ahead and add 5p to both sides to get my p's on the same side. So 9p equals, and this cancels, 7. Yep, so divide both sides by 9, and p equals 7/9. All right, you guys, let's go ahead and do number 7 here. It looks a little bit different, but you will see it ends up being so easy. We have negative 10 plus the log base 3 of n plus 3 equals negative 10. Okay, so let's undo this one step at a time. The first thing I notice is I can remember when you're solving, whenever you attempt to solve an equation, no matter what type of equation it is, the first thing you should say to yourself is, can I get the variable by itself? So right away, I notice some low-hanging fruit out here. I can get rid of this 10, so I'm going to be one step closer. So I'm just going to take the low-hanging fruit, and that cancels. It actually makes this side 0, which you will see in a second makes the whole thing a lot easier. Then I have, log base 3 of n plus 3 equals 0. Now, you have to think to yourself at this point, what do I know about logs? Is this set up to look like anything I know? And it is. If you look, I think one of the very first things we did about logs, this is our base, this is our exponent, and this is our value, okay? You can also think of it when I make that stupid heart that you guys never think looks like a heart. You start with your 3, and this gets rid of the log. To the power of 0, oops, sorry you guys, ran out of room. To the power of 0 equals n plus 3. And here's where that 0 becomes important. So now I have no log. I've just got to solve this. If you have an exponent and a number, that's just another number. And what do I know about the 0 exponent? That just becomes 1. So 1 equals n plus 3. Subtract 3 from both sides. And I'm just going to switch it around. I like to write it like this. -2. Okay. Which one should we try next? What looks complicated here? Gosh, none of them look super complicated. Number 12, they have the same base log, so you can, I'm just going to write here, in case you're not listening, I am still talking, saying some interesting stuff. Number 12, they have the same base, log base 9, so you just set them equal to each other. The same with number 11. But we have something squared here, so maybe you might need help. Let's do number 11, solving a quadratic. I mean, I hope you don't at this point, but number 11, they're both base 12, so we can go ahead and set up as v squared plus 35 equals -12v minus 1. The first thing I ever want to do, especially when I see my a value is just going to be 1, is put it all on one side and see if I can factor it. So I'm going to add 12v and I'm going to add 1 on this side. So I'm going to add 1 to the 35, and 12v is going to be by itself because there's no other like terms. So I have v squared plus 12v. Remember, it has to be in order of v squared of degree to the 2. 12v, which really means to the 1 power, right? And then I have plus 36 equals, and then this has canceled, so I have 0. So now I can factor. So I have two numbers that add up to be 12 and multiply together to be 36. It's going to be 6. This is a perfect square, actually. 6 plus 6 is 12, and 6 times 6 is 36. So I can actually write that as x plus 6, it's v plus 6 squared, and this will make it a lot easier to solve, equals 0. So our answer is just going to be -6. Okay, just one number. For this one, it must just touch at -6 and go up. Okay. Let's do one more like number 7. Let's do number 10. And then the rest, I hope you will be able to figure out. Number 10 is -6 times log base 3 of x minus 3 equals -24. So the low-hanging fruit, divide both sides by -6. Then we just have log base 3 of x minus 3 equals +4. So to get rid of the log, 3 to the 4th power equals x minus 3. 3 to the 4th power is 3 times 3, which is 9, times 3, which is 27, times 3, which is 81, equals x minus 3, and then add 3 to both sides. So 84 equals x. Cool. All right, I'm going to post these up, send y'all a remind, and let me know if you have questions on any of the other ones.